Okay, so you guys are going to be taking your test this Thursday, and we have a lot of material that's going to be on this test. So chapter 5, that went over polynomials, finding zeros of polynomials, rewriting polynomials as linear factors and or quadratic if it wasn't irreducible over the real numbers. We looked at the complex zeros. 6.1 through 6.8, that was composition of functions, finding inverses of function, exponential functions, logarithmic functions, solving all those different types of equations, graphing those things. Let me go back to chapter 5. Chapter 5 also had graphing your rational functions, so finding your vertical asymptotes, your horizontal asymptotes, slant asymptotes if they exist, any holes in the graph, and graphing those. Chapter 11, that was the conic section. So that's where we looked at parabolas that faced left, right, up, or down, ellipses, hyperbolas. And then we jumped into chapter 12. 12, we looked at systems of linear equations, and we used matrices to solve those. 12.5, we looked at partial fraction decomposition, where we took a complicated fraction and we rewrote it as a sum or difference of others. 12.6 was non-linear systems of equation, and 12.7 was non-linear inequalities or systems of non-linear inequalities. So graphing those and shading in the region that they have in common. We have a few problems in front of us that you should know for the exam. First one, if f of x is equal to 2 raised to the x plus 2 power minus 1, answer the following questions. So first part was to graph this. Let's call this one. So if we're going to graph this, I know that we can use shifting with this, transformation of functions. We have this x plus 2 in the numerator, or not the numerator, the exponent. That plus 2, that's shifting it horizontally, and this shifts our graph opposite direction, so to the left 2 units. This minus 1 in here, this is shifting it vertically, and this shifts it down 1 unit. And it shifts, these shifts are on the parent function, which is y equals 2 raised to the x power. So we talked about the general shape of exponential functions when the base was greater than 1 and when the base was between 0 and 1. I don't like how that looks. And so the general shape looked like this. Where we had a point here at 0, 1. And we had a horizontal asymptote at the x-axis, y equals 0. So let's look at that graph and let's do some shifts. So if we shift that to the left 2 units, that point at 0, 1 is now moving over to left 2 units. So that's now negative 2, 1. And then if we look at that point negative 2, 1, and we shift it down 1 unit, that new point is negative 2, 0. So this point here, using our transformations, is right here. Since we're shifting this down 1 unit, our asymptote that used to be at y equals 0 is now at y equals 1. So our graph looks similar to this. So wants to know what is the domain and the range of f of x? The domain of this, we don't have any trouble spots. We can use all real numbers, so negative infinity to infinity. Our range, well, we're never going to hit -1, and we're going to always have y values above -1. So it's -1 to infinity. Does f of x have an asymptote? If so, what is the equation of the line of that asymptote? Well, we already said it, it was y equals -1. And when I wrote this down here, this should be -1 also. Okay, so now we want to find the inverse function. So recall when we find the inverse function, we swap our x and our y values from our function. So we have our function y is equal to 2 raised to the x plus 2 power minus 1. Let's swap our x and y values, and then we're going to solve for y. So we have x is equal to 2, y plus 1 minus 1. So let's isolate our exponential piece so we can add 1 to both sides. So we have x plus 1 is equal to 2 to the y plus 1. We want to get that y plus 1 exponent down from and not in the exponent. So we can use properties of logs to do this, or we could just rewrite this as a log. If we rewrote this by definition of a log, this is log. The base of our exponential, remember, is the base of our log of what we're taking right here. X plus 1 is equal to our exponent. And we're almost there. We want y by itself, so we need to subtract 1 on both sides. And so if we subtract 1 on both sides, we get y is equal to log base 2 of x plus 1 and then minus 1. And this is our inverse function of f of x. When it wants the domain and the range of the inverse function, well, the domain and the range of an inverse function are just swapped from the original function. And so our original function domain was negative infinity to infinity. That's what our range is for our inverse function. So the range is negative infinity to infinity, where our domain is what our range was for our inverse function. If I didn't know what those domain and range was, I could look at this and figure it out. Remember, we can't have log of a negative number. What we're taking a log of, it has to be greater than 0. So we could set that x plus 1 greater than 0 and solve. And notice we'll get x is equal to, it has to be bigger than -1, which is what we have up here for our range for our original function. So -1 to infinity. Okay, so that was the first question. Let's see if you guys have any questions. Our next example is g of x equals the natural log of -x minus 1 plus 2. It says graph g of x. What is the domain and range of g of x? What is the equation of the asymptote for g of x? Find the inverse function of g of x. And what is the domain and range of g inverse of x? So again, we can look at this as transformation of functions. Our parent function is y equals the natural log of x. And recall that that general shape looked like the following. So with the transformations on this graph, let's talk about it. So that -1 inside here, this is going to reflect, that -1 is going to shift the graph to the right one. If we shifted this to the right one, we now have this piece. What is, I'm not done yet. And then we have that negative in front of the x. So that's changing the signs of my x value. So if I'm changing the signs of my x value, that's a reflection across the y-axis. So this negative in here, this is a reflection across the y-axis. So if I take this, that was at 2, 0, and I reflect it across the y-axis, my graph now looks like this. This point that was at 2, 0 is now at negative 2, 0. And then the last thing is shifting this up 2 units, this +2. So this point that was at negative 2, 0 is now at negative 2, 2. It's not the perfect graph, but you get the gist. So what is the domain and what is the range? The domain are all values of x which are greater than, it's greater than 1. I'm not sorry. I can look at this and see. So looking at this, just do this. My domain is my asymptote before was at the vertical asymptote was at x equals 0. And when we shifted it to the right one, that was 1, but now we reflected it, so that's to negative 1. So the domain is from negative infinity to negative 1. The range are all real numbers, negative infinity to infinity. The asymptote is x equals negative 1. Is the vertical asymptote. And then we want to find the inverse function. So let's rewrite that as y equals. So we have y is equal to the natural log of negative x minus 1 plus 2. So let's isolate the natural log. So we could subtract 2 on both sides. We have y minus 2 equals the natural log of negative x minus 1. Okay, so rewriting this in exponential form, we get e raised to the y minus 2 power is equal to negative x. Oops, I never swapped my x and y values. Let's swap x and y. So this is now x minus 2 equals the natural log of negative y minus 1. Okay, so now rewriting in an exponential form, our base of natural log is e. So we have e is raised to the other side, which is x minus 2, is equal to this negative y minus 1. So let's add 1 to both sides. And so doing that, we have e raised to the x minus 2 power plus 1 equals negative y. And then multiply through by negative 1, we get y is equal to negative e raised to the x minus 2 power minus 1. And that's our inverse function. So g inverse of x is equal to negative e raised to the x minus 2 minus 1. And again, the domain and range of these functions are swapped from the original function. So our domain is negative infinity to infinity, and our range is going to be negative infinity to negative 1. So you should be able to solve logarithmic equations. And so we have 3 in front of us right now. So let's look at this. Y is equal to log of 1/16 of 4. So let's rewrite this in exponential form. So the base of our log is the base of our exponential. Our log is always equal to the exponent. So this is 1/16 raised to the y power is equal to 4. So we can use a rule that if we have the same base, then we can set our exponents equal to each other. So I notice I can manipulate these to either be both base 4 or both base 2. Let's do both 4. So let's rewrite 16. That's the same thing as 4 squared raised to the y power equals 4. We can bring that up by making the exponent negative. And so this is 4 to the negative 2 power raised to the y is 4. Power to power is multiplication. And so this is 4 to the negative 2y power equals 4. We've manipulated it so that the bases are the same. So we can set our exponents equal to each other. And so we get negative 2y equals 1. And divide by negative 2, we get y is equal to negative 1/2. So the next one, we have log of x minus 2 plus log of x plus 2 is equal to 2. So we want to rewrite this so we have a single log equal number. And so we're going to use rules of logs, where if we have a sum of logs, we can rewrite it as a single log by multiplication. So this is the same thing as a log of x minus 2 all times x plus 2 equals 2. So this is, I'm going to distribute this out. So this is log of, and I could have done this later. This is the difference of squares. So this is the same thing as x squared minus 4 equals 2. So once you have a single log equal number, then we can rewrite this in exponential form. If the base is not shown, we know it's base 10. And so we have here x squared minus 4 is equal to 10 squared. So x squared minus 4 is equal to 100. I'm going to use the square root property. So let's add 4 to both sides. So we have x squared equals 104. Take the square root of both sides. We get x is plus or minus the square root of 104. It looks like 4 goes in there evenly, so we can pull out a piece. Square root of 104 is the same thing as 4 times 26. And so square root of 4 is 2 root 26. We have to check our answers when we're dealing with log equations. We can't have a log of a negative number. So notice if we put negative 2 root 26 in here for x, that gives me a negative minus a number is a negative. So this can't be negative 2 root 26. If I put positive 2 root 26, that's going to give me a positive number when I plug it into the first log, and it's positive when I plug it into the second log, so we're okay. And so the solution is just the positive in this case, 2 root 26. Okay, so our next logarithmic equation, we have 3 logs hidden here. So there's a couple ways I can approach this. We can get all the logs to one side of the equation and we can rewrite that as a single log, or we can use the fact that if we have the same base and we have something in the form of log base b of a equals log base b of capital B, and then we can say that a is equal to b. And so if we just rewrite the one side as a single log, so that plus sign tells me multiplication. So this is log base 5 of x minus 1 all times x plus 4 equals log base 5 of x minus 5. So this tells me that x minus 1 times x plus 4 has to equal x minus 5. So let's expand. And so if we expand the left-hand side, we get x squared. This is going to be a 4x minus an x, that's plus 3x minus 4 equals x minus 5. It's a quadratic equation, so we want to get everything to one side of the equation. Let's subtract x and add by 5. So if we subtract x on both sides, we get 3x minus x, so that's plus 2x, and negative 4 plus 5. That would be a positive 1 equals 0. So I notice that does factor. This is x plus 1 times x plus 1, or x plus 1 quantity squared equals 0. So when is x plus 1 0? It's when x is equal to negative 1. We're going to have a problem because if we plug that value back in, wherever we see an x, I get a log of a negative number here, and I get a log of a negative number here. And so this doesn't work, and we would say that there's no solution.